Thanks, Frank. It's good to be back here this morning. Everyone hear me okay in the back? Okay, great. Something interesting I found on the internet last night, and I emailed it to my wife because she's a realtor. Maybe some of you saw it, where a realtor made an appointment to show a home to a couple. And the realtor recounted later that, well, you know, she hadn't been there for a while, and she had called, couldn't get a hold of the owner, so took the couple to the home, unlocked the front door, let them in. She was busy with paperwork and returning a phone call, and she said, just go ahead and tour the home yourself. So a few minutes later, this couple at that point was in the back bedroom, and the realtor heard screams, and she ran back there, and there's a dead body on the floor of the bedroom. And it was a woman's body, turned out to be the owner of the home. Realtor recounted later that, yes, when she stepped inside the front door, she did notice an odor. And, of course, the body was the odorant and certainly unwanted matter that had to be cleaned. It was a source for dissemination of pollutants. And after the primary source is removed, the rest of that environment has to be clean. Something to keep in mind. We haven't talked much about dissemination.
Did they buy the house?
They didn't buy the house. You might say it was a dead issue after that. Actually, I've got another one. Nothing surprises me anymore. And so one day I got a call from a fellow in California. It's got to be California, right? And he said, here's the situation. We have a woman in this condominium who's reacting to something. She is convinced that it's coming from the condo adjacent to hers. And she said, we have been in there and we can't find any connection between the two. And is it possible that something could move from this other condo to her condo that she's reacting to? And I said, well, you've got to have a common pathway. Pollutants, irritants, sensitizers have to be moving from the condo in question to hers. And so it is possible. It's just getting the right people perhaps to look, do some airflow studies, so on and so forth. He said, well, let me tell you the rest of the story. And he said, this is what happened. There was a man who owned the condo adjacent to hers. And one day he just decided that life wasn't worth living anymore. And he locked his front door. And he got into bed. And he stayed there until he died. He starved himself to death. Well, months went by. The mortgage wasn't paid. The bank foreclosed, put it up for sale. Someone bought it. The bank handed the keys to this individual who went in, unwanted matter in the bed. And the next question I got was, the body now was just a mass of mold. And if we tell you the different types of mold, can you determine how long that condition has existed? Because this is relevant to the situation of the woman in the adjacent unit. And I said, you know, we don't have forensic mycology at this point. Not like looking at fly larvae and saying, well, it's, you know, been at least 48 hours or something. But so dissemination of pollutants from sources, and the sources don't have to be active necessarily. And then talking about environments and cleaning, one thing that disturbs me greatly is the fact that each year we have more and more preschoolers in daycare. Mike's addressed this before in presentations to a great extent. And I speak about it too whenever I can. It's appropriate to indoor environmental quality. 2 parents work, preschooler, 1 or 2, put in daycare, full-time. How is the decision made to select a daycare environment? Well, it's usually, is it on the way to work? How much does it cost? Is it cheap? They'll visit it, and first thing they'll ask is, do you have space? What does it cost? And when they should be asking, you allow sick children in here. How well trained are your daycare staff? Do they teach these little children to wash their hands? Do you promote hygiene? Are pesticides sprayed for control of insects, and if so, how often? Who cleans your carpet, and how do they do it? You've got toddlers crawling on the carpet here. These are the important environmental issues. They're affecting, literally, the next generation. We have this steady increase in hypersensitivity, asthma, and respiratory allergies in children. I've often referred to daycare environments as seething pits of infectious disease. And many are. Many state programs are lacking across the country in terms of inspection. I've talked with state sanitation people. We inspect every daycare once a year. Okay? What happens the other 364 days? You know, who's monitoring this here? So these are just some things that I've been thinking about and prompted with between last night and this morning. And again, we have to keep coming back, and it came up this morning. The key is education. It's always education. And getting the message to the right people, as Mike mentioned. And one area that I also dealt with over the years, not only in the U.S. but on a global basis, is medical waste management. And just to echo what Mike said, from my own experience, just one project, for example, was in Europe, in Central Europe, in Hungary, 3-year project funded by USAID in medical waste management. Well, I couldn't hope to get anything accomplished unless I had the buy-in from the director of the hospital, who typically was a physician, often a surgeon, hard to get a hold of, doesn't want to come to a meeting. But the only way we could be effective is to get buy-in and support from either the hospital director or his technical director, who was in charge of environmental facilities. Work from the top down, okay? Project in Africa. You go into a rural village in a developing country, you just can't walk in and say, you know, we're from the U.S., we know what your problems are, and we're going to tell you how to fix them. No, you have to work within their culture. And the first thing you do is you develop a relationship of trust. And you get buy-in from the village elders. And you find out what it takes to meet with them and what type of gift you should take and how you address them and whether you shake hands or you bow. And we need to do the same thing here. How do we get the attention of the people that make a difference? And will they support us in our efforts to educate the general public, the insurance industry, all those that we've been talking about? Okay, back to the science. How do we measure cleaning effectiveness? After we finished yesterday with our panel discussion and everyone was leaving, a lot of talk about clean is going to be relative to your particular application. So, how clean should a horse barn be? Or a chicken house? Or a daycare? Or a food production facility? And so forth. So I think we all have the idea that these are the types of standards, recommended protocols, thresholds, detection limits, and so forth that we need to focus on and develop. In addressing this, let's see where we are, and I have some relevant examples today in that regard. First, as you see here, there's no universal criterion methodology or technology for the measurement of clean. We have companies here that have ATP detection, instrumentation, and so forth. That's good. It can't necessarily be used for all applications, all environments, everywhere. There may be something that's a little more relevant and important that we can measure. This is due to a variety of different types of clean, each of which has varying requirements for effectiveness and acceptability, going back to what Mike's been emphasizing in terms of risk. There's always an acceptable risk. Risk is never zero. So this dictates quantitative measurement, and we need something that's quick and rapid. So if this building, when we're done, as Mike mentioned, is in chaos, and a crew needs to come in and clean it, okay, when they're finished cleaning, how different is it then from what it was before they started? And how do we measure that? Is it dust? Is it a particular biological marker, particulate marker, size of particulate? All of these things are relevant. Certainly dust collection. Dust in the semblance of various microtype particles associated with soil and fibers and biological organisms, and we've talked a little bit about that. Lots of folks like to do culturable or viable sampling for bacteria, for fungi, or certain markers. Ergosterol, which is the primary sterol of fungi, and studies have been done. I have a colleague in Canada who's spent years looking at ergosterol and thinking, you know, if we can go into a building and collect air and surface samples at critical locations and analyze for ergosterol, will that correlate with other findings in the building, complaints of the individuals? Can we say and calculate a total fungal biomass number and say this is a problem environment? There must be moisture problems because there's too much fungal biomass. You can correlate well with viable culturing. You have to process samples using chromatographic methods in the laboratory, not something you can do in 30 to 60 minutes, which is really what we need. So if there's water damage and mold in here, restoration company comes in, does the job. When they leave, they're loading up their trucks. They want to know in the next hour, preferably, are they finished or not? Is the environment now acceptable or not? We need a rapid test. We need appropriate markers. Some examples, we've talked about special environments, hospitals. So here the focus would be an infectious marker, perhaps. Staph aureus, E. coli. Here we're collecting viable organisms. Cleaning effectiveness criterion may require a threshold of 0. This is interesting. Normally this is not the case in most environments, where we say requirement is no detection for this particular marker. Now the government did that when they were cleaning up the buildings contaminated with anthrax spores, and I don't have an objection with that, as long as everyone understands that however many samples you collect in that environment, 20, 50, 100, 300, if all of them are 0 for anthrax spores, doesn't mean there aren't any there, okay? That's the nature of sampling. You're not looking at the entire environment, every microgram of dust. I was asked to do a post-mold remediation verification protocol a few years back for a nursing home that had been flooded. One of the hurricanes came through in North Carolina. This nursing home was on the eastern shore. A mile away from the nursing home, the local sewage treatment plant overflowed, moved downhill to the nursing home, so it was not just floodwaters, but sewage. Moved individuals out, so forth. Patients obviously were elderly. Many were cancer patients. There were some AIDS patients. a lot of concern about immunocompromised individuals. And so when I wrote the post-remediation sampling and analysis protocol for the contractor that was doing the restoration and remediation, I put in there that in all the samples that are to be collected in all the different areas, and the focus is mainly on surfaces. That's the remediation that's being done. Okay? Minimal air samples, because again, whatever's in the air came from a source, came from a surface, came from a material. Microorganisms don't reproduce in the air. In fact, I gave a presentation to NIOSH one time, their interdivisional bioaerosols conference, and I made that statement. A researcher said, "Is that true? Bacteria don't reproduce in the air?" I said, "No, nothing reproduces in the air unless a woman gives birth on an airplane." So I put a specification in there for absolutely zero detection, no recovery at all of Aspergillus fumigatus, which I talked about yesterday, the major opportunistic fungal pathogen. Remotolerant, loves to grow in the respiratory tract, upper and lower. Usually in terms of infection, we have those specific zero requirements. This is from the Frank Porter Graham study that I went over yesterday, Total Building Cleaning Effectiveness. And that's the high-volume small surface sampler that was developed years ago. It was actually a cooperative effort between EPA and industry up in Bend, Oregon. And it's been modified several times now. This happened to be, as you can see, the nursery-type area. And you can collect dust samples before and after and analyze them, which is what we did. And again, if you look at the paper or the report that was eventually turned into EPA, volumes and volumes of data, thousands upon thousands of samples, carpeted plus hard surface areas. This takes time. Again, it's not a rapid method. It's a research tool. Okay? But in order to collect dust and analyze it, this is one of the ways that it should be done. Bacteria on surfaces. So food contact type environments. We can use contact agar plates that we press on surfaces, incubate them. Again, it's going to take at least 24 hours to read those. Swab samples or wipe samples. After cleaning, I'll go into ATP detection in a moment. Interpretation of results is based on previously determined threshold criteria. Who determines these? Where do they come from? Okay, this is the research component that needs to be done. And it's a problem inherently over time, it has been over years, is who is going to fund the research to generate the database that we need to give us our previously determined threshold criteria. And again, it should be done in different environments. I'll show you some data from ATP measurement in a school environment, in a dental laboratory, and in an office building. And we can research our method in laboratory, but then we've got to take it out into the real world environment and build a database. And then hopefully geographically we include those measurements, those data from all of those different points. And then we come to a conclusion. You know, things we need to consider. There's at least 7 different climatic regions in the United States, the continental U.S. How does that affect what we sample, what we analyze for? Part of the science of doing the research. A lot of sampling goes on for residual fungal contamination, pre and post remediation analysis. How can we do it rapidly? I'll take you through a brief, commercially available fungal assessment method. Again, we may have target molds as markers or indicators, such as Aspergillus fumigatus, Stachybotrys, in that nursing home contaminated with floodwater, sewage. I said no detectable Aspergillus fumigatus. It shows up, one colony, one sample, you go back and clean. We do the whole sampling all over again. Contractor said, sounds good to me. I don't want a liability issue, and I want to be able to present credible results that say we've done our best in cleaning and verifying sampling and analysis. So I'll take you through the fungal enzyme detection. Again, we're always going to say previously determined threshold criteria. The research has to be done to generate the information for us to sit down and decide as a group for your application what's going to work. And we want it fast, okay? Pressurized sewage backflow. I look at this and I can't help thinking, gosh, I hope nobody was sitting there at the time. So after the remediation, obviously, and at different points in the process, sampling will need to be done. Okay, culturing can be done. Again, it's going to take time, at least 18, 24 hours. Can we target E. coli or other coliforms? Yes, we can. I'll take you through a molecular type enzymatic method in that regard. Endotoxin and ATP. These are possibilities, but they're everywhere. Okay? ATP is in every living cell. Endotoxin is everywhere. Comes from the cell walls of gram-negative bacteria, and it's universal as a contaminant or pollutant. How about clean room technology and verifying? Whole different set of criteria, guidelines, threshold limits. Okay? We take wipe or lift samples for particulates. Again, we can use ATP, ergosterol, so forth. Need to generate the database. Complex research methods to quantify the effects of cleaning have been developed. I'm going to take you through some of them, but we have a long, long way to go. Their widespread use has been hindered due to the factors I have here. Some require highly technical skills. Something has to be brought back to a laboratory where highly skilled people use very expensive instrumentation to take several days or weeks to generate a result. So some are not acceptable and eliminated very quickly. They're otherwise labor-intensive and time-consuming, limited availability. Maybe there's just one manufacturer, and they're located somewhere in Europe, and you need a component for your instrument. Doesn't work too well. Lacking an acceptable framework of standardization. Again, we have to generate lots of data, and maybe it's just not suitable for rapid and routine cleaning effectiveness measurement. I showed you a photo of the HVS3. It's a good research tool. It's not for rapid measurement of what's been done an hour ago. A device that was very interesting called the BM dust detector, developed over in Europe. The Danish Institute of Occupational Health did a lot of research with it. Basically, they used these gelatin foils, which looked like a clear sheet of plastic, and you would actually, it was a defined area, and you would set this on a surface, and then they had a roller, and you had to train yourself to apply just 1 pound of pressure, okay, so many times, and you take that and you put it into a light reading device, okay, and based upon the light scatter, diffused or transmitted light, you had a numerical, a quantitative measurement of clean. So you could do that before, then someone comes in and cleans these surfaces, you do it again. Instrument never fell below the cost of $3,000, and then only one supplier for the foil. And again, it turned out to be a great research tool to give us a sense of what's going on with cleaning surfaces, but never made it into the mainstream and was never redesigned or adapted for some type of rapid use. I mentioned ergosterol, not high on the list of probabilities here. Again, we need a chromatographic process, and ergosterol is literally everywhere. We would need an extensive database. Same with endotoxin. Okay? There's residues of endotoxins on those glasses that we're all drinking from out there. It's on every surface in this room. Okay? Gram-negative bacteria are ubiquitous. What are we talking about? Okay, here's two bacteria, gram-negative bacteria. You can see the cell walls. This is a freeze-fracture process, and it's been colorized. Well, there's a particular molecule, lipid A molecule. That's the endotoxin. That's reactive. When these cells lyse, they desiccate, cell wall material breaks apart, we have liberated endotoxin. The world is covered in endotoxin. Why? Because these organisms come from the soil, and so they're everywhere. And endotoxin is stable. That's an advantage to it. Okay? The only way you can break down endotoxin is to cook it or incinerate it. In order to do analyses, I remember we would have to have our lab bake our glassware at 160 Celsius, or no, 300 Celsius oven for at least 3 hours to destroy the endotoxin. May have certain applications, but not for rapid testing. Bioluminescence, enzyme, and then immunoassay. Let me take you through these. Bioluminescence. Detectable ATP. ATP is in every living cell. It's the energy source. It's not usually available as free ATP until that cell dies, ruptures, lyses, and that ATP is released. ATP is stable, and again, that's in its favor for measurement. Detectable by an enzymatic reaction, very quick reaction. Luciferin luciferase, this is how a firefly glows through that reaction. Research has shown correlation of ATP units with bacterial colony-forming units. Rapid, portable, affordable, different testing systems are available, widely used in many industry applications. Basically, you collect a swab. You can specify a defined area. A swab typically will contain its own reagent as you put it back in its sleeve. Break the capsule and then insert it into a light-reading instrument that will give you numbers of luminescence, whatever you want to call those numbers, different types of detectors. So this is what I just explained. Lots of variability. Just two photos from the total building cleaning effectiveness study where they actually damp mopped the walls. We didn't do the ceilings. All of the light fixtures, all of the windows, window sills, vinyl flooring, ceramic flooring, carpet, everything. Massive study. Thousands upon thousands of data points. Mycometer, you might be familiar with that. This was presented at the Healthy Buildings International Conference in 2000. And one of the developers from the University of Copenhagen, Morten Raislav, approached me and he said, someone told me I should talk to you about this because you're involved with cleaning and research and so forth. And I said, talk to me. And he had this system that uses a particular fungal-associated enzyme that you can see there, N-acetyl beta-D hexosaminidase, only emanates from fungi and related vegetative material. You can't use this method if you go into a bakery, for example. You're going to get a lot of false positives. But otherwise, it works well. They focused on using it, though, for post-mold remediation purposes. Yet instantly I said, you know, you have the potential here for rapid cleaning measurement. And he said, well, we already have some data. And basically you collect a swab, defined area, expose it to a reagent that will extract the enzyme, and then you look for a color change. You put it in a fluorometer. Comes with a little kit. Initially, several years ago, it was very costly. It was about $4 a sample. The cost is down now, and I'm hoping they'll focus again on cleaning. Here's what they had. Cleaning categorizes A, B, and C. A, background level, mold spores present with no visible dust or dirt in buildings with no moisture mold problems. This is normal, acceptable. We don't live in a sterile environment. B, elevated level due to accumulated spores from lack of cleaning. Somewhat analogous to, I didn't mention it, but if you look in our paper, Indoor Air from '97 on the total building cleaning effectiveness study, we looked at 3 potential markers, biological markers for cleaning effectiveness. Cladosporium spores, mold spores. We looked at aspergillus as a marker for water damage somewhere. And we looked at actinomycete bacteria, same way. And we could see peaks and valleys associated with various problems. The building had water intrusion at one point. Levels went up. There's still potential for some of that work to go forward. And then C would mean this is above background, above acceptable. This would indicate active mold growth on the surfaces. And so this is what it would look like. Okay? So up to 25, not above normal background, 25 to 450. This is only from their limited research data. And they don't have, apparently, additional funds, or they didn't the last time. I met with them to do a much expanded study, have someone do it independently, maybe refine this range some more. But this actually worked. I mean, in the laboratory, piece of moldy wallboard, high numbers, a dirty desktop. We went around and looked for dusty furniture. We were in this range. And then we looked at a visibly clean surface that we knew had routinely been cleaned in an office building. And we were within that A category. Okay. Antigen detection. This isn't the only company that does this type of work. It happens to be one that contacted me, and I had a study going on relevant to moisture and mold in randomly selected homes in Utah County, Utah, and they said, we're interested perhaps in when you have your culturable analysis results, let's compare it with our rapid system. What this does is this can detect organisms specifically at the molecular level, or we can measure specific antibodies to certain target agents, also do PCR, that type of thing. So it's very customizable in that regard. It comes as a kit, as you see here, and you actually make up dust suspensions. You use dust from surfaces. And we can collect dust from vertical surfaces. You don't see the dust, but it's there. And most of you are in the cleaning industry. You know that dust adheres to everything. You put it in this 8-well biosensor strip. And then what we're doing is it's an immunologic reaction that then is translated into an electric signal. So it's an immunochemical electric system that we have here. Again, you get detectable units in this device specific for your organism. So it may be a bioterror organism. In fact, our collaboration had to stop because the federal government came down on them and said, we will give you this monster contract, for all of these bioterror agents if you start now. So we didn't get to finish our collaborative work. What's key can be customized. So do we want a specific sewage indicator, water damage indicator, either bacterial, fungal? Food industry, listeria, E. coli O157H7. We could go on. So readily affordable, usable, economical per test. Do it right there in the field. Okay, I'm going to take 10 samples in this room, and research has generated this database. We have a guide for interpretation, similar to what I showed maybe for the micrometer, same type of thing. The research has been behind it to show that quantitatively these rapid measurements are an indication of the job being done, accomplished. We have cleaned that environment. Of course, training's involved. It's always, you have to collect the sample properly. So, just to sum up what I've said before and you've heard now for 2 days, comparative research is necessary to identify optimum cleaning effectiveness measurement methods for specific target markets across different environments for different materials and surfaces and different applications. I know that sounds very complex and, 20 years worth of research. No, it doesn't. And Mike mentioned this yesterday, and that is that we have a lot of this information out there. People are testing in food processing industry. People are testing after mold remediation. People are testing after different types of critical cleaning. People are testing in clean room environments. We have a long way to go in hospitals, nursing homes, daycare environments, which are critical. And we should perhaps focus more on not only environmental markers that indicate a changing ecosystem, but specific pathogen targets as well. Such research conducted in a cooperative mode of effort will serve to define the many aspects of clean and help to establish consensus standards of care for cleaning effectiveness within the industry. We're talking a lot of standards of care. So just go to your manual. What is your surface, your material? What is your application? Okay? All backed by research data in a database that's been done credibly, different locations, in the lab, in the field. Okay? You're protected from liability. You're using good science. You're making a difference in the cleaning industry. And you're showing the public, the directors of the healthcare facilities, the building managers, the insurance companies, what clean really is, what it means, and how it can be effectively measured. Thank you very much.
Once again, we have time for questions. If you'd like to go to the microphone on either side.
Dr. Cole, I'm Bob Robinson of KIVAC, and I probably swabbed half your guys' hands during this symposium over the last couple nights. We've been out swabbing restrooms after we've cleaned them, and I noticed your data. There was tremendous variability before cleaning, and that's kind of what we've experienced with your hands. We grabbed your hands, and you didn't know we were going to be grabbing your hands and swabbed you. But after you go and scrub really good, it's amazing how there is consistency. And we have found in restrooms, using a particular cleaning method, that we're getting very consistent readings with ATP. I just wanted to pass it on. The information up there was all over the board, and we're seeing very, very consistent data.
Mm-hmm.
So.
Yeah, I appreciate you mentioning that. And just to point out, there are intricacies involved here. And again, you didn't have a lot of time to absorb those data, and they were just a few slides of them to give you a sense of what we're dealing with here. But there is a difference between unfinished wallboard and painted wallboard and wallpapered wallboard and different types of wallboard in terms of composition and so forth. We have to know our materials, our surfaces. What is the coating? What is the paint? What is the sealant that we're looking at? We've got to generate this database. You go around taking a lot of measurements, okay? So you're generating data that's useful to you in your application, hopefully to others. So hopefully your device has a memory storage capacity, and you can recall that, download it, and so forth. These are the things that need to be done. These are great projects and I'm not trying to, promote this because I'm from academia, but these things can be done very well, very economically, using students. I have terrific graduate students. Those of you in academia, same thing. They're low cost, high motivation, and they have to learn, and this is great experience for them. And we crank out some good data, some good research. They get a publication out of it. So don't think, tens of millions of dollars we talked yesterday about some studies. Yeah, it will take that. But others, no. We just need to do the same good design protocol study in several locations, hopefully get the same data and information, create our database and a scale of interpretation. Put it on a little card in your pocket, in your wallet, with your luminometer, that type of thing, or whatever your marker is. This is all doable, folks. Oh, I'm sorry.
I think you were just about ready to touch on the UV lights. I know any good carpet cleaning company is going to use a UV for pet stains, and I tell you, the first couple times you see that, it's almost embarrassing, and then you get used to it, and the homeowner's always the one that's embarrassed. Well, it wasn't a very big leap from there for us to, I think it only took us about a month to figure out, let's use this in the restrooms, and we use it as a training tool also, the before and after. So if you could elaborate a little bit more on UV, I mean, because that's a visual right then and there, too.
Oh, yeah. Probably everyone here knows there are compounds that fluoresce, certainly from urine, and a lot of carpet cleaners use those, and not uncommon for a carpet cleaner to be called and just ask the individual. Maybe there's no evidence otherwise, but say, well, do you have a pet? Well, yes, but, we control the pet, and the pet doesn't do anything on the carpet. Okay, well, we have a little test we'd like to do. Draw the blinds, turn out the lights, turn on the UV, and the whole carpet is glowing. And you can see the spots where the cat or the dog is wet, or the toddler, or again, there needs to be a care and feeding of your carpet, care and feeding and cleaning, I guess I should say. In terms of remediation, UV has limited application unless you're going to put it someplace. A couple of studies shown that they put it into the airstream from the air diffusers into the waiting room where there were active TB patients or there were AIDS patients and that type of thing. But otherwise, it just really doesn't work well. The bulb gets covered with dust. It minimizes effectiveness. You have to have distance has to be as close to the bulb as possible. You have to measure the wattage on a routine basis. But yeah, as a device for rapid assessment, and I think we could probably expand in using that UV. Actually, something occurred to me based on what Mike said earlier in terms of environments going to chaos and degrading, and pollutant levels will eventually decay over time just through use of an indoor environment. And a classic study done in home environments with cat allergen. Cat allergen is extremely potent. Those who are allergic to cats know that. My wife is one of them. If she were to pet a cat and then touch her face, you couldn't recognize her in a few minutes. Be so swollen. And in fact, if she walks into an environment, she's asthmatic, she'll start to react. The allergen is very sticky. It adheres to surfaces. Cats lick their fur. A lot of that high-powered antigen is in the saliva, and so it flakes off their fur. Dander from their skin is very potent, and it's everywhere. Classic study that was done said, okay, let's look at homes that have cats, and let's throw the cat out. And then let's keep monitoring, air and surfaces, and to see how long it takes for the cat allergen level to get down to the point where it was before there was a cat in that environment. The time it took was 20 weeks, 5 months. Now, this is just routine cleaning. Just throw the cat out and then do your normal vacuuming and hard surface floors as a homeowner. 5 months. How much better can we do with a recommended cleaning regimen for people who, let's say, just bought a house or intending to buy an existing home, yet they have allergies and asthma? That's a whole other area that we haven't even talked about. The demand for hyposensitive home environments is tremendous, tremendous. I've talked to my wife a number of times. I've even said, we have a son who's a builder in Boise, Idaho, and she's a realtor, and I said, I'm kind of busy right now with what I do in my day job, but I'm surprised no one has actually started a business, realty company, and everything that would go with it to promote healthy home environments. Now, we do have some. They're low VOCs in terms of sealants and paints and insulation and so forth. But again, we could expand that. I think the market would be tremendous. People would be willing to pay a few thousand more to know that they won't be reacting to certain things in the environment. Anyway.
Yes. Typically in the cleaning industry, our tools for measuring cleaning effectiveness have consisted of measuring the process that we go through. Did we use the right water temperatures? Did we use the right tools? Did we follow the right steps and procedures? So we're measuring it on a process level instead of on a results level. From your perspective, how important do you feel the measuring of cleaning effectiveness with respect to quantitative results, how important is that to the cleaning industry moving forward?
That's a great point. The end result is a reflection of what you did in the process. And so it's extremely important. And as the research moves forward, and again, we're all here because we're in agreement, I hope, that research should move forward in these different areas that we've covered the past 2 days. And that could include assessing the process as we move toward the goal of this environment will be clean according to the parameters that the research have generated. We have our interpretation scale. I'm not sure if that's what you're getting at. Should we measure the process as we go along, as well as the end result?
I'm looking for quantitative tools for measuring cleaning effectiveness, whereas typically we've measured cleaning effectiveness by looking at the process that the person goes through to clean and saying, oh yeah, it must be clean because they follow these steps, instead of actually measuring the results of their cleaning efforts.
Well, sure, and that's what I'm suggesting here, that this is what we need. And research, I think, I'm very optimistic that there can be certain measurement methods that are rapid. They have relevant markers that are applicable to a number of environments. And that's where we would want to start, where these rapid methods, an hour or less, will give us great information. We have an interpretation scale, but you can use it in a food service environment. You can use it in a nursing home, in a daycare. Tweak it a little bit in a hospital and that type of thing. Oh, absolutely. Yeah.
And I think before, and we'll have one last question, but one comment I want to make is we've been talking about this clean standard, trying to use this technology to develop a clean standard. And I think the important thing to recognize is CIRI has talked about this, is that what we would be identifying is what are those markers, what is the level of clean you're trying to achieve, without telling you how to do it. I mean, if you could do it with a toothbrush and cat spit, God bless you, go knock yourself out. But the goal will be when you get done, this is the level of clean that facility should be at, either daycare center or whatever. So it's not trying to identify the process, it's trying to, there's a term that they use in Europe where there's cleaning science, which is pre-competitive research. And that's what we're trying to talk about here. We're not going to tell you how to make your equipment or how to make your chemicals. This is the goal we want to get to. This is the level you need to achieve, however you do it. And that can be with green chemicals, it can be any kind of approach.
And then before Steve's question, just to add on to that, I think what we're looking at with these measurement methods are having them used before the cleaning as well as after, to show a difference. It may not impress the homeowner, but it's going to impress the manager of that bank building that's paying a company a good sum of money to clean that building, especially if there's a problem in that building. And the question comes up, you're the cleaning contractor, what's going on here? Well, every time we come in, okay, we take some pre-cleaning samples, and then we take them after. Here's the data. This is your building. This is a reflection of what's going on here. This is your ecosystem. So, still problems in that area in terms of mold remediation. Still folks that say, hey, if you can see there's mold, why sample for it? Well, you're going to sample on the back end. It's nice to know what's on the front end. Again, insurance won't always pay for it, but there could be certain organisms there that you want as definitive markers. Aspergillus fumigatus, maybe Stachybotrys, maybe something else that's contaminating a product in a production facility. A few years ago, a company contacted me. It was a contamination of, I think it was dishwashing liquid. There was this unusual environmental fungus that got in. Well, where's it coming from? How can they keep it out? That type of thing. Pre and post. Steve.
Yeah, I hope it's a short question. Following on the previous query about the use of black light, ultraviolet lights for qualitative inspection of things that will fluoresce. I've had for many years, I use an ultraviolet inspection lamp that has a tube both for long wave ultraviolet and then short wave ultraviolet. So the long wave ultraviolet is going to be closer to the violet end of the spectrum. I expect that's the black light, the ultraviolet we usually use. However, the short wave ultraviolet, I've seldom, if ever, had anything that I've used without studying it that fluoresces. I'm guessing, unless it's used by geologists or mineralogists, are there any applications for the shorter wave ultraviolet where I don't find much that fluoresces, that obviously does fluoresce in the longer wave UV? Any experience with
Not that I'm familiar with, no. There's another component here too, and maybe this isn't the best example, but it's a real world one, not necessarily relative to UV. I appreciate that, Steve. Another area for active research. But a colleague of mine, some of you know him or are familiar with his work, Dr. John Roberts up in Washington State. I like to call him Dr. Dust. And he's done some great studies. Some of them are just little quick things with a few students and a few homes and buildings and that type of thing. One, for example, was that he looked at 10 homes. 5 where he had people take their shoes off as soon as they walked in the front door or back door, whatever it was. I guess it was front door because then there was carpet. And the other 5 that just kept their shoes on. And then he actually measured, took samples of carpet dust over time, and you could see the difference, the track-in, the higher concentration of fine particles. Okay? The big particles come off in the first few steps. And in the middle of the living room carpet, as you came in the front door, the fine particles come off. Okay? And then just next scene, picture the toddler crawling on the carpet. What was associated with those fine particles? Was it lead? Was it a pesticide residue? What was it? But one thing that was really interesting, just something quick, and this was right after the Hoover Dirt Finder vacuum cleaner came on the market. And Hoover asked him, they said, would you like to do some research? And he said, well, yeah, send me a vacuum first and I'll see what we can do. And so they sent him a vacuum. And he went to a home that had a high traffic hallway. Carpet was 12 years old, had never been cleaned, rarely vacuumed. Okay? And he signed up all of his students and he said, I want you to vacuum. He said, you're going to need to take turns until the green light comes on and no more particulates are being removed from the carpet. And so sometimes I ask my students in class, I said, okay, take a guess, how long till the green light came on? Usually there's, 20 minutes, an hour. Somebody say, 5 hours, 16 hours. And the point he was trying to make was made, and that is that you can remove what's on the surface and then a few centimeters down from the surface, but you never get the deep down embedded dirt by the base of the carpet fibers. And so when we're talking about doing measurement methods, we have to know what we're measuring and how to measure it effectively. Someone can come in and shampoo, the carpet in every room of a house for $29.95, and they've moved the pollutants around, and they've left chemical residue, okay? And then someone can come in and sample the surface of those carpet fibers. Looks great, but what's embedded down by the bottom, the base, there's pollutants there. It hasn't been cleaned. Unwanted matter hasn't been moved out. So All of these things we have to address in the whole research perspective and framework. But this can all be addressed. That's why it's called research. It's gaining knowledge to equip us to learn and then use that in practical application.